Applications and extensions, building functions. Here's our problem. Let p equals x comma y be a point on the graph of the quadratic function f of x equals x squared minus 8. So before we read any further, let's think about that curve. That is a parabola, which is like the parent function but shifted 8 down. So the vertex is 0, negative 8. So here's our parabola x squared minus 8. Problem A says express the distance d from P to the origin as a function of x. So we're talking about the distance. We can use the distance formula, and that is x2 minus x1 squared plus y2 minus y1 squared. But we'll substitute in the specifics from this problem. Now we'll simplify that expression. And here is our distance function, the square root of x squared plus f of x squared. Now, the first question says, what is d if x equals 0? Well, if I solve that algebraically, I would need to know the value of the function at x equals 0. That is negative 8. I'm going to square negative 8. I get 64. And then the square root of 64 is 8. I also can see that I could graph it right away. I could graph d of x using desmos or some graphing utility. I'm going to do that. So there in green is the function d of x. And remember, what's the value of d at x equals 0? We knew it would be 8. And there we've proven that d of 0 equals 8. We've shown that on the graph. We could also show it algebraically. What is d if x equals 1? I want the value of the green curve at x equals 1. So d of 1 equals 7. And then it says, for what values of x is d the smallest? Well, those are those relative minimum values. We could use calculus, and that's your next course after pre-calculus, to figure that out. But for now, the graphing utility will help us see that the minimum values, d is smallest at x equals plus or minus 2.739. So that was one of our application examples.